Thank you. Hi, everyone. How are you guys doing today? Hope great. My name is Shmyhelskyi. I'm engineering manager at Hitachi Vantara. And today I want to tell you a story of my team, how we moved the project from monolithic architecture to microservices, what challenges we faced down the road, what mistakes we did, and we did a little bit, and how could we avoid them, and how hope it would be useful for you in your projects. So in today's agenda, we have a brief overview, what the differences between microservices and monoliths, background of our project, the journey itself, what we did, and a little bit of retrospective, how we did well, what we did poorly, how we could do it better. And I'll wrap up with a few key takeaways for you and your teams. So without further ado, let's get started. Microservices versus monoliths. So monoliths is basically a type of architecture where all of your business logic lives in one server. It's usually have one database. It's easy to develop because it doesn't require a complex infrastructure. You just deploy, test, and monitor one server, and everything works for it. The downside is harder to maintain as the project starts growing. The technical depth accumulates, and every new feature is harder and harder to add. Sometimes it's not reliable. Let's imagine if a reporting feature have a bug and the user uses and it's crashed the whole application, so the whole application is down. And every change requires a redeploy. So the opposite to monoliths are microservices, where we have a lot of single responsibility services. They usually have a separate database. It brings you a flexibility of picking the technology for each service, so you can tailor your solutions and pick the right language to or technology that suits the solution the best. It allows you issues isolation. So in that case, if reporting service go down, if stopped correctly, the application is supposed to continue working just fine. It's usually the much simpler code. So because it's single feature in each code base, so the code would be simpler and it's easier to maintain and extend because you're just adding the new service and it's a new code base once the infrastructure is set up. The downside of this approach is you need to invest in infrastructure upfront to make it actually work for you. So it's harder to monitor, it's harder to deploy, so you need to invest in automations, it's harder to do testing, and if the changes happens or the bugs happens, it spans across the multiple services, it could become a complex change. So what should you use for your project? And there is actually no right answer because at a different point in time, the answers would be different. At the very beginning of the project, when you don't know if it's actually needed on the market, who would be your customers, what would be the key features, it makes sense to invest your time into the business logic and to focus on it. So monoliths bring this. It could give you the opportunity to do this without investment in infrastructure. But later on, once the project grows, once you have more resources assigned to it, more customers, it makes sense to transition to microservices for the further scale. And this point in time is natural for majority of the project. So it's important to just know when and how to transition it correctly without many mistakes. So a little bit about the project before we transition. So when I joined the project, it was a small startup, like 10 developers most. And it was a single feature product and single product company. We did a data catalog. The main use case was the customers connect their data sources. We run some analytics. We classify the data and calculate the data quality and provide them output in the shape of dashboards and visualizations. So the technical stack is really simple, and the main purpose was to just develop something fast and ship it to the market. So MongoDB as a database, Express.js and GraphQL at the backend. And the only reason we had the GraphQL is because we found the library GraphQL Mongoose Compose, and it allowed to create a CRUD endpoints easily without extra effort. So we had them, and that's the reason why it's GraphQL, and JavaScript and React on the front end. shortly after I joined the project, like 6 months, it was acquired by Hitachi Vantara. It's digital department of Hitachi, which is kind of like huge corporation. They started investing in it. The team grow, the customer base grow. We started aggressively expanding features. And we realized that we have this one code base for 50 people, and it's very hard to work like this. So we had our justifications to move from this architecture. So let's just briefly focus on them. So as I mentioned, one of them was ease of development for multiple teams. We had around like 50 developers, and we decided to split it as a Scrum team, and microservices allowed us to assign different microservices to different teams, and they would have their own like areas of responsibility without interacting with others. The next one was move from JavaScript to TypeScript. Again, the team growth, the project growth, and if we could have something that would give us more safety in development, we want to use it. So TypeScript with its types provide more safety. The next one was scalability. So we wanted to scale the analytic model, the one that did the data quality computations and data classification for the customers on demand. So we wanted to extract this as a separate service and scale when they requested. And the last one is reducing tech debt. We had quite a few because the development was really rapid, and it's not actually must-have when we migrated to microservices, but it was always hard to find the right time to allocate, to eliminate the debt, and we decided why not to use this transition in architecture to just schedule also some tech debt elimination. In addition to technical justification, we had quite a few business justifications. So one of them was reusability, as our project became one of many other projects under Hitachi umbrella. So, and we realized that they're all in active development, and some of their features are actually looking very similar. So the idea was if all the projects starts developing their own microservices, and if we need feature from different project, we can just deploy their service to our product, and vice versa. They can borrow ours if needed. And another one was different product packaging. So we extended our feature portfolio, but we realized that not all customers actually use all of the features. And the message from sales team was that some prospects doesn't want to pay the full price for the product where they're going to use just a few features. So microservices would allow us to create separate packages with subset of features and sell them for reduced price. This was our justifications, and we had enough of them, so we decided to act. And at the beginning of this journey, we had, like any other teams, a question whether to rewrite everything or migrate. And I believe many developers would agree how tempting it is to rewrite everything, but we were told by project management team hard no. So we had a commitment for customers. We couldn't just disappear for six months and then return back with the same functionality just on microservices. So they didn't want this, so we went for iterative approach. This brings us to our first microservice, chat microservice. And POC, it stands for proof of concept. If proof of concept was actually microservice architecture, chat was completely legit product feature. It's fairly simple. It's like comment section for YouTube where the internal users can communicate, start the threads, mention each other, and it's not related to existing business logic. So actually, it's a good candidate to develop, and then the rest of the project could use it. We gathered with my team, we started brainstorming, we created really comprehensive conference documentation with technical specification. We focused on database designed for this particular service, endpoints, and React components, all of this. And actually, we brainstormed a lot because it was actually a new activity. It's not something that we've done before. And we laid down kind of like foundation for the future microservices. So later on, we just used the decision made there. So a couple of decisions is we still continue to use Mongo, just decided to not to interfere with our existing Mongo. Just for every new service, we start a new database, so the rest of the projects get used the same. REST instead of GraphQL. So we spent a lot of time debating this, but we actually never used the main benefits that GraphQL provides, like caching, like partial data loading. The main reason why we used to do GraphQL is because ease of development at the backend, but we realized that if we're going to have multiple microservices, we had a Polo client that is pointed to our monolith. We have to create and manage multiple clients on the front end, or create some sort of the gateway that combines all of the services. And it was just a POC. We didn't know if we want to continue with microservices. So REST seems more appealing, and we didn't have time to invest in these gateways. Another was TypeScript. That's obvious, probably. And the last one, micro frontends. A couple of things contributed to this. So first, we wanted to ship our services all together, so to make integration as easy as possible. So database, service, client, and all projects within Hitachi Vantara, most of them, they use React and they use UIKit, kind of like internal components library, and they look basically the same. So if we export some client components, they would be in the same team. And also we used White as a build tool, and most of the projects did it too. And we had an internal tool called App Shell. So it's basically, the main idea was to make the common navigation for different projects, but it used micro frontend. So and module federation under the hood. So we knew if we export React components, most of the projects would be able to support it and import them. So integration for this chat microservice was kind of like, you deploy, we provide the Docker scripts, you deploy it, and then import React component, you pass the entity ID, and for this entity ID, all the messages are grouped and threads, and then the path to deployed server. That's the integration. That's how it's supposed to be. So we pitched this technical spec to stakeholders, to project managers, to engineering managers. They liked the idea. They gave us a green light, and we started working on it. We integrated it with Monolith. We integrated it with one more project, and it was kind of successful. So we decided, let's build all of new microservices, all of new functionality with microservices. And that's how we moved from monoliths to microservices. I'm just kidding. We had a first obstacles. You're here for listening something. Our main problem was we haven't invested in infrastructure. We focused on each individual service straight away. It was very compelling, and it was something interesting, and we just left infrastructure out of scope, and it's caused us issues. First one was user authentication. We didn't have any services to provide user identification. And actually, our monolith was responsible for generating tokens and validating them. But the company standard was Keycloak. All the rest of the project used Keycloak. And we realized that our service is supposed to work with all of this, with monolith and with Keycloak as well. And if some projects have a different tools with them. And we realized only after implementation, and once we started supporting other teams to start using this service. So we had to make a quick changes. So we made them configurable. So we passed JSON file with the configuration in environment variable. And then this JSON file had the URL where to send the token to validate, and the rules how to map the response to internal user model. And for our project, we configured it to be pointed to monolith, and for the second project to the Keycloak. Later on, we removed this functionality from monolith and just deployed Keycloak for us as well, and fixed this. Another issue is service-to-service communication. For our project, it was deployed in the Docker, and we had internal Docker network, so we could rely on it. It wasn't the case for the second project, though, and we had to figure out something fast. So we decided, not ideal solution. We decided to create a service user, kind of. And for user-generated requests, we use the user token to pass to the next service. For not user-initiated requests, we generate a GVT token for this service user. It's not visible for customers. And then we use token and pass it in the header. Again, not ideal, but it was really late at the at the release stage, and we had to do something. It was like the fastest solution. The last one is that I want to talk today is the code duplication. We didn't realize it immediately at the first service, but like on the third, fourth, we realized that there is a lot of code that just being copy pasted from one repository to a different one once we start working on it. And for solving this, we created a GitHub template that's kind of like was a skeleton for our future microservices with deployment scripts and automations. And then we created custom NPM registry and tried to extract as much as possible into the packages and reuse them in the project. But again, we realized it's pretty late. So we spent time to go and update existing ones, existing microservices. And we're supposed to invest and do this from the very beginning. And these all are actually the symptoms of one issue, that we forgot infrastructure. We focused on each individual service and forgot how it's going to look overall and how fast it can grow. So before the section what went poorly, I want to quickly summarize what went well. So planning and technical spec. So the one that we created for each individual service, we actually updated it with implementation details at the end, and it acted kind of like documentation. So when somebody else needs to integrate the service, I'm just sending the link and maybe one meeting after it. And it saves me a lot of time. Comparing to when we need to integrate someone's service and there is no documentation at all, there is a lot of meetings and it's really unpleasant. The next one, managing expectations. So we identified the point when we have to migrate and that we need to do this. We created a plan, even not ideal plan, but it was a plan. We estimated it, we acted on it, and we integrated. So and we communicated with the project management and engineering management about this, and we actually pitched and they agreed to our justification. So I think this was a good thing. And incremental approach, it's controversial, but in my opinion, the main idea of starting everything from scratch is to have the tech dev free code base. But because we did this for the first time, we introduced a new one. So anyway, we have the code depth, but we at least didn't block our customers. Maybe next time this would be in the what went poorly section, but this time it's in what went well. So what we did poorly? First, underestimating complexity. So it was really fun to do something new, to write the code in the clean, fresh code base, but we didn't realize how fast it can grow. And only like once we had like 10, 15 services, we started investing in automation, in deployments, scripts, in the observability metrics, and testing, actually. So we did this too late, I think, and we wasted a lot of time. Actually, about the microservices, it's all about time and what you spent after it and on support of the system. Communication with other teams. We invited our team, our project managers, to the call once we drafted the technical specification, but we forgot about the other teams from the different projects who are going to use the service as well. And this this forced us to make these decisions with service-to-service communication and user management very, very late. So if we could invite all the stakeholders, it probably would have saved us some time later on. No unified architecture plan. Again, underestimating complexity was more about infrastructure deployment. This was about how services communicate and like macro picture of all system. And we definitely messed up here. Insufficient testing strategies. So we did test coverage for some critical components, but again, time was pressuring and we left out everything else. Context switches in the software development are expensive, but with monoliths, you just context switching when you work on feature and you have like critical bugs, somebody ping you, hey, fix this, customers need them, this is tomorrow. And when you do context switching in monoliths, you're just switching from the task to a different task. And when you do it in the microservices, you're also switching from the code base to code base. So it's way, way more expensive. And if there is something that we can do to prevent the bugs happening or just make them less, we should do it. and that's where we're supposed to invest more. And if I want to summarize overall, so for me, the main complexity in microservices is not about each individual microservice, but to build the system that is flexible and where you can make changes really quickly. Because if fixing one simple issue, but in all of your microservices takes a couple of months, then there is no benefit in it. How could we do better? So focus on infrastructure early on, automations, tests, deployments, all of these things. Improve communication. So microservices are also about communication, more precise documentation, cross-team meetings, increasing awareness of what you're doing. Because if there is dependency on your service, it's not the standalone project anymore. It's just a building block. And once the change is made, we need to make efforts to let everyone else know that the change is made and they need to tweak their services as well. Straighten testing, so do the functional testing if there we have time. But more testing, yeah. Sorry. Invest in training. So never bad thing before processing before starting something major in your project. We could have invested a little bit more time in training, and I believe if I did more preparation, we would spot these infrastructure issues way earlier. So I want to wrap up with a few takeaways. Shift from monoliths to microservices are natural. We just need to learn how to do this. Preparation is the key. We need to think not one step ahead, but actually 10, 20 steps ahead. Not what it's going to look like when we have monolith and then one new service, but what will it look when we have monolith and 10 new services, 20 services, and then ask the question, always challenge this plan. How easy would it be to update this or add a new service? And then this would influence each individual service architecture as well. Communication matters for microservices, and we need to invest time in the documentation, communication, and if it's written, it's better. And flexibility. So we need to have a plan, but we also need not to be afraid of pivot if we face any obstacles. So prepare the plan, act on it, but if realize the mistake, just fix it and go ahead. With this being said, I want to say thank you for listening to me today. I hope it was useful for you or your projects. I'll be glad to answer your questions here or just add me LinkedIn and let's chat. Yeah, thank you.
All right. We have a handful of questions already. First question. So what do you guys sell apart from hard drives?
Yeah, I actually, my team doesn't sell anything. So actually Hitachi is a big corporation. They sell trains, they sell energy, I believe. But what we do, we are a digital department. So Hitachi Vantara, they just do software. That's it, yeah.
Okay. How are you observing your microservices and container cluster?
Yeah, so we integrated open observability tools and we're collecting logs. Some of them are just automatic, so we connected to Docker containers and they collect output. But also we adding some custom logs for the user actions and for the processes. And later on, yeah, just it's more for DevOps. They analyze. Our part was to collect it, and also we collect the traces. I believe they all connected from the client and they to the database. It's collected, so we use the traces to analyze the performance and how the data flows. Yeah.
Do you use Prometheus or other CNCF tools or something else?
Sorry.
Which tools do you use? Like, do you use standard CNCF things? Like
open observability. Open.
Can you? Oh, wow, these are jumping ahead. Okay, I'm gonna go from the bottom because these are older. So microservices are supposed to be share nothing. How do you decide whether to duplicate common code or extract into a library?
Yeah, so the rule of thumb for us, actually, if it's used in a 2 or more microservices, we want to extract it. It's not like we're extracting the business logic, because sometimes it doesn't make sense. It's more about utils, some tokens for validation, some middlewares that are actually applicable to most of the services, and deployment scripts. But yeah, deployment scripts can be extended, so we just hold them in the templates in the GitHub. Yeah.
Okay. Can you expand on the business justification? Did you get much pushback?
Yeah, it depends from who. So our business justification, as I mentioned, was first of all to create a product packaging and deploy just a few microservices. And this was kind of like combined idea from project management and the engineering. So didn't get pushback on this. And just the second one, I believe, was to reuse a component, and that was project management also like this, because it's speed up the development of all projects. So I don't think we get any pushbacks on the business justification. They like it. Yeah.
How do you identify the boundaries of microservices?
So usually it's a feature. Yeah, I mean, or like it comes natural, honestly speaking. So there is no like set of rules. So it depends on the context. But I mean, our project managers are really technical ones. So it's usually when there is a new product area, new product feature, it's kind of like isolated and it works correctly. So we don't need to like guide them how to lay down this specification. But it's usually depends on the context. It's hard to answer like.
Okay. You mentioned documentation was important. Is there any tool that you would recommend?
Yeah, the one that your company is currently using and knows. So we use Atlassian, we use Confluence, and that's where all of our documentation stays. But this would be not correct answer if your documentation lives in Notion. I don't know. So where everyone knows, that's the best place to.
Okay. Any questions in the room?
I'm gonna be a bit rough. Like when you said about the problems, user authentication, communication between microservices and code repetition, like these were so obvious, and by anybody for anybody who ever worked on microservices platforms before. So wasn't there anybody in the team who had experience of working on microservices previously with microservices architecture, and shouldn't be key takeaway to get a person like this next time? Because sorry, these are, you know, like basic things that you need to think about when you design microservices architecture.
Great question. Thank you. Yeah. So I mentioned probably in the presentation, this was the first time we worked with the microservices. And actually the good side effect that we got, the team grew. And now that they are the experts in microservices. We had a team that used to work in the startup. They just worked with the monoliths, and that was the first experience. I understand it might be the silly mistakes, but at this point, we didn't want to invite somebody new. We wanted to do it in-house and grow the team like this. Yeah.
Okay, like for me, key takeaway will be to hire a consultant next time, even though I hate the word consultant. Thank you.
Anyone else? Last chance. Okay, I don't think there's any more here, so we will wrap up there. Please, round of applause for Aaron.
Thank you.
All right, our next speaker is now coming up. So Lilia, please, round of applause for Lilia.
It's fine.
It has to be very close. Is it working? No.
Okay. This one? Yeah, this one working. Yeah, 1 second. Hi all. So yeah, I'm working in Amazon, but I'm working on another service, not on DynamoDB. DynamoDB we use so as a customer. So let's get started. A little bit introduction. Why DynamoDB at all was created in 2000. So yeah, so the main requirements to DynamoDB, it was to create something very reliable, because any outage cause significant loss in financial aspect and in customer trust. So DynamoDB was designed specifically with the target to preserve any rights. Yeah. So based on these requirements, there is key principles behind the DynamoDB design. So yeah, I want to highlight it again because in Amazon, we actually a few times a day, we are facing networking issue, which is causing availability drop or partition failure. That's why it's very important to have all the components reliable. So the key principles behind the DynamoDB design, it's probably everyone is like aware. It is replication. Yeah, replication using consistent hashing. Consistency is facilitated by object versioning. Consistency among replica during update is maintained by quorum write and quorum read technique. Also, DynamoDB is using gossip protocol to detect the failure of the nodes. And DynamoDB is itself is decentralized, means any nodes can be removed and add automatically without manual intervention. Depend on the spike or if there is node goes down because of networking issue. So we quite often just taking nodes out, and if there is spike, we can automatically increase or bring them back. So that's how it works. And yeah, this is the core design technique. Next, core concept of DynamoDB. This is quite straightforward. I believe anyone who was working ever with DynamoDB, they knew this core concept. So basically, it's a table structure. One of the core components. Table, it's the same like in the relational database. Tables include items. Items, basically, it is the collection of data, which is include attributes. Attributes can be different types, primitive types, complex types, or document types, like list, map. Yeah. So the key benefits of the tables that is schemaless means you can add any attributes anytime to DynamoDB. Why it is key benefits? Because it's flexible. You can store different attributes depending on type. So as the user needs change, for example, or items, you can add or remove attributes for specific items without alerting the table schema. And each item only stored relevant attributes, so unused fields are not stored, saving space and simplifying management. Yeah. Yeah, I forgot to slide So basically this, the table, example of table, you can see we have different type, custom vendor, admin, not all of them are using the same attributes. Yeah, and it could be different types. Okay, next one, core concept of DynamoDB, it's partition key. It's something similar what we have in relation database. It's a private key, but what is important here that partition key actually play important role when you're creating how you partition your data. Because DynamoDB hashing the partition key to determine where the item storage will be located. And if there is a low cardinality of this partition key, you can end up with a hot partition. Means a lot of requests will come to the this partition. And what it's mean on the level of DynamoDB, then, for example, in past, we had an issue where we're creating the hot partition and we can't serve all the requests because half of them was just throttled by the DynamoDB. And when it's throttled, means customers will face just 5x. And it's kind of, impacting the customer in bad way. The businesses actually suffer. So this is partition key. Along with partition key, we have a composite key, which is composite key is actually included partition key and sort key. Why we need sort key? It's for so basically it's for efficient efficient way to query data from DynamoDB. So partition key is responsible for partition key, while sort key is responsible how your data will be stored on this partition. It's other on ascending order, means all the data will be stored just to close to each other. And when you will query this data, means for example, with between or for example, if we use order date and we need to query the order between some data, and they will be on partition store exactly to close each other, makes the query perform well. Okay, now I want to touch, I will just sum up. When the partition key is best for use case with unique identifier, ensuring that it's spread across partition. Compose key ideal for related items like order group by customer, enabling efficient retrieval and organization data within the partition. So, managing capacity and preventing for partition in DynamoDB. Something which is slightly touched. Just I will check that. So I think. So DynamoDB has two different modes. It's provision mode and on-demand mode. The different in provision mode that you set specific capacity level known as read capacity unit and write capacity unit based on expected usage. DynamoDB in on-demand mode, you don't specify it, but DynamoDB still has limitation, default limitation, after which you will be anyway throttle, even though if you not specify the read capacity units and read capacity units. On-demand mode is more costly than provision mode. Another core concept of DynamoDB, it is indexing. Same It's kind of similar what we have in SQL database. We have this B3 indexing and stuff, but here in DynamoDB we have local secondary index, and we have global indexing. So local secondary indexing is quite limited. And so basically why it's limit, because before you will creating DynamoDB table, you should know ahead your access pattern to the data, because you can create LSC only at the beginning. What is the difference? How the local secondary indexes actually looks? So basically, you have partition key, which is you defined from the beginning, and as a part of this partition key, composite key has sort key. If you know that will be pattern, access pattern different from one which is you defined from the beginning, which is composed key, then you can create LSC index, local secondary index. It will be basically another combination of your partition key and sort key. So you change the sort key, but you preserve the partition key in this case. Yeah, just that I'm following. This is core concept again. Yeah. Key points. So same partition key, different sort key, strong consistency. Once I will start talking about the global secondary index, we will find out that it is doesn't guarantee the strong consistency, while the local secondary index is guaranteed. And it is kind of obvious, because the data will be stored on the same partition. Efficient sorting and filtering. So benefits: no data duplication across partition, cost effective, and the limitation that you can create just 5 secondary indexes at the beginning. Global secondary index. Global secondary index, it's absolutely different. Here you defined another partition key and sort key. What does it mean? It means that data will be duplicated across the world. If you're using DynamoDB across the world, I mean, with creating global secondary index, you will duplicate your data across different partition, because here you defined another partition key. Yeah, and it is eventual consistency. Means any updates which is done to DynamoDB, after some time, you can query with global secondary index, and it will reflect not right away after the writes. Key difference, just to sum up: query within the same partition, different partition key. LSC doesn't support, JSC supported. Additional sort key, both support. Synchronous consistency, LSC is supported, JSC doesn't support. Independent read-write capacity settings, yes, this is something important. LSC doesn't support, while for global secondary index, you can define different read and write capacity. Depends on your access pattern to the data. Yeah, and global secondary index could be created at any time. Once you observe new pattern, you can create a global secondary index. Okay. So all this core concept actually is a part of data modeling in DynamoDB. It's very important to understand what is DynamoDB has, because based on this, different. So Difference between SQL database in DynamoDB that when you're creating the tables in DynamoDB, it's very good to know ahead your access pattern, how you're going to query DynamoDB. Different patterns, for example, I will show the example later, like social network data model. For example, we want to create another Instagram. And apparently, we need to know how to efficiently query all the list of followers or efficiently query all the posts and show this feed data. That's why it's very important to know access pattern before ahead. While for SQL database, you're just creating entities and tables, and you rely just on join when you query these tables. Okay, in DynamoDB, data is often organized in a single table design to consolidate all the related data into one table. The design is, while the SQL database is about normalization data, DynamoDB the opposite, about the normalization data. Means all the duplicates data could be stored and all the data could be stored in the same. It is even encouraged to store every data in the one single table rather than splitting across different tables, because DynamoDB, just simple as it is, doesn't support join. Yes. Okay. Let's look at the example. So this is a relational database and how database schema will looks for social network app. Yeah, there is patterns which we know ahead what we need, what we want to have, and when it comes to DynamoDB. Yeah, so basically, just because of I was thinking that there will be time constraint, and I just cover one of the pattern, which is get following list by user ID. So this is on the bottom. This is the example of DynamoDB table. Here we're creating one item, which is user, and it has user and ID. We created two sort key, which is count and info. Count has attributes followers, following, and post. Info, in the same time, has information about the customer. Next, we are creating another partition key in the same table, which is user ID and followers, and list of the followers, and the same for the following. So what is benefits it brings to us? For example, when you decided to add to user A, user B in the follower list, and you need at the same time to increase user B followers count by 1, and user B to user A is following list, and increment user A following count by 1. You can use transaction write items in DynamoDB, which is guarantee you that it is if all the requests will be successful, then the operation will be successful. If anything is failed, then the transaction will be rolled back. This is one thing. So yes, to improve access pattern in Dynamo, DB, just to summary everything what I just covered before. So choose high cardinality for partition key, and use compose key to support varied queries within partitions. So basically, yeah, then higher cardinality than beta. It could be combined with something, as we see at the example. So basically, you can add followers ID and U, differentiate it. Or you can shard actually the ID. For example, you have product which is very popular. It's product, for example, 1, 2, 3. You can add -1 and product 1, 2, 3 -2. That's how you're going to shard this your product, your item. So leverage secondary index to create flexible query path. Use single table design to consolidate data and support complex access patterns. Applied sharding and efficient query practice to balance load and enhance performance. Continuously monitor. Yes, you have with DynamoDB, you can monitor your access pattern and adjust when you see that something is very popular, for example, and you can flexible adjust it and leverage secondary index. Yeah, and I want to, it's not going to be in depth, but some advanced Dynamo capabilities I want to cover. Again, I was for some reason thinking that I will be on the time constraint and didn't went very deep. Dynamo Stream. Dynamo Stream, so basically it's powerful feature in DynamoDB that enables application to respond to real-time changes in data. So basically it's like listener. You can create what kind of records is going to listen on the item in the table. Is create, update, or delete. And Dynamo Stream capture these events and it can store in a log for 24 hours, or what it also can do, you can integrate, for example, Dynamo Stream with Lambda. That's what we have that's what we're using in our service. So basically, DynamoDB is sending notification and then triggering Lambda and Lambda doing some logic. It's DynamoDB Stream is a very powerful feature. Key usage of DynamoDB Stream, you can use it in real-time processing. Application can process data in it's like real-time almost. Data replication and synchronization, you can replicate change across tables or synchronize data across system. Auditing and monitoring, track data changes for security, compliance, or debugging by recording each insert, update, or delete action. Yeah, as I mentioned, Stream works well with other AWS services like Lambda and Kinesis. Global table for cross-region replication. We personally don't use it. We are using DynamoDB as a one master, and we replicate data across the world. Because DynamoDB we're using on the control plane, so basically we don't need this low latency access, and we find with some period of time inconsistency. Yeah, so but global table for cross region replicas, it's something which is we are calling multi-master. Means in different region you can actually have different instances of DynamoDB, and it could be master. And in one part of the world there could be writes, and in parallel there could be happen another writes, and all these writes will be resolved. The conflict will be resolved. Yeah, so basically how the DynamoDB is resolving conflict on the writes. It's a last writes win. based on timestamp. And it's useful for disaster recovery and what is the most important for low latency access. And then closer to user, then the latency will be less. So basically that's it.
Sure.
So I'm working on CloudFront, and this is CDN.
Okay, next question. That was what Amazon services you work on. Next one, use single table, wouldn't it lead to data duplication and therefore require too much AWS costs?
Yes, using single table. It depends how. As I mentioned, it is trade-off which is you're taking. But with duplication, you're increasing the query performance because you're basically query only one single table, and you don't need to query a few tables and using join, which is as many of us know, has the performance fine.
Yeah. How would you compare? That's okay.
Sorry.
How would you compare Dynamo with Mongo? And like SQL, it seems like Mongo and Dynamo are very similar.
Yeah, I never use Mongo. So basically, I was working with PostgreSQL, but it was on-prem solution in past. I believe, when you come and when it comes to clouds, and you want to replicate it across the world, I can't imagine how we are going to use kind of SQL database like Postgres. So yeah, I can't answer on this questions because I don't have experience, but I believe it depends on scale and on the application. If it's an on-prem solution or the local one, I believe it's cost effective to use Mongo or Postgres rather than DynamoDB.
Okay. What are the benefits for using DynamoDB instead of SQL? Maybe not. Kind of similar. About that. If I want to learn more about how to start using DynamoDB, can you recommend any sources or maybe a course?
Not course, but honestly found very, while I was preparing my presentation, I used a lot Amazon documentation. Yes, it's quite nice, especially when it comes to data modeling, and it's described the mental model, which is you have to pick up once you design the tables. There is quite a lot of examples. I took one of them, but it is actually very nice written. So one of the things.
Okay.
Yeah.
Okay. Any questions in the room?
Oh no.
I have a very basic, nice question. Let's say I have a small data set and SQL is simpler for developers to use than Dynamo, obviously. Would I get on small data set, would I get quicker responses from Dynamo versus Aurora?
Aurora, I never worked with Aurora. What is this? Is it also cloud-based?
That's Aurora is AWS service for MySQL and Postgres.
Okay. MySQL. If you have very small data set, which is you can query by key value, then probably DynamoDB will perform better. But when it's come to SQL database, means you can't query by key value. But DynamoDB position yourself as a key value data store. That's why it was actually also created, because for most of the use cases, which is Amazon.com has, like retrieving session or some trivials like examples, you actually want to access by key. That's why I believe DynamoDB will perform better than Aurora.
Okay, so I'm mostly about the response time. You also think the response time?
Response time.
Because we want the data.
Yeah.
The quickest. Let's say we don't care about the cost. The data has to come in the quickest way to the users.
Again, Aurora, as you mentioned, it is a SQL database. How you query Aurora?
In case of Aurora, there will be like using AWS SDK from Node.js.